Okay, so today we're going deep into AI agents.
Yeah, those things that are like learning to use our computers and phones.
Exactly. All those graphical user interfaces we're always on.
Yeah, like how's AI going to navigate that world?
And you know what's cool? We've got some really interesting stuff to look at today.
Oh, yeah.
Like there's this whole discussion going on in Reddit's RI Agents subreddit.
Oh, wow. I've seen that. It's pretty active.
Super active, over 100,000 members.
Lots of people interested in this.
Then there's this technical paper. It's a bit dense, but it introduces this new type of GUI agent called UITARS.
UITARS, huh?
Yeah. And we've also got some news about a company, Unsloth AI. They're all about making AI training faster.
Oh, that's going to be important with how big these models are getting.
Totally. And to top it all off, we've got this article, kind of a think piece, predicting that these things called vertical AI agents are going to be everywhere by 2025,
So like specialized AI for every industry.
basically. So, you know, we've got our work cut out for us today, got to connect all these dots and figure out what it all means.
Definitely. But hey, for someone like you who love to get into the details and really understand things quickly, I think this is going to be a really fun one.
I hope so.
Yeah.
You know, I'm always up for those ha-ha moments.
You and me both. And, we'll make sure to cut through all the technical stuff, just the key insights.
Absolutely. We want everyone listening to feel like they really get it, not just bombarded with jargon.
Right, like informed, not overwhelmed.
Okay, perfect.
Okay.
So let's bring in our expert to help us unpack all this.
Great to be here.
So let's start with the basics. What exactly are we talking about when we say AI agents?
Okay, well, the Reddit community on AI agents is a good starting point.
Yeah, that's a lively bunch.
For sure. They generally see AI agents as LLMs, large language models, but with a twist.
A twist. Okay, like what?
They can actually use tools.
What? It's like actual software tools.
Yeah, or execute functions. Like they can actually do things.
Not just talk about them.
Exactly. They can either do this completely on their own, autonomously, or with some help from us humans.
Human in the loop, they call it.
Right, exactly.
Okay, so they're not just like passive generators of text anymore. They're actually interacting with the digital world.
Exactly. They're actors, not just talkers.
So one of the threads that caught our eye was a review of this research paper called ChatDev.
Oh, yeah, ChatDev. That one was interesting.
You know about it.
I do, yeah. What they did was, like, simulate a whole software company, but run entirely by AI agents.
Whoa, wait, a whole company?
Yeah, like, they had different agents for different roles, the CEO, the CTO, programmers, designers, testers, the whole works.
And they all work together to actually build software.
Yeah, they use this kind of classic, like, waterfall model, where everything happens in these set phases, one after another.
It's structured.
Yeah, very much so. And the reviewer on Reddit, they thought it was, like, super relevant for anyone interested in coding agents, which I know you are. It's like, a cool way to explore how AI could handle these big, complex projects.
Absolutely. But, in that same thread, someone brought up a really good point. They were like, how does ChatDev compare to those newer, more collaborative frameworks like AutoGen and Crew AI?
Yeah, it's a good question. Like, is the future of AI agents going to be these kind of rigid role-based systems or more like, fluid, dynamic teams of agents?
Yeah, it's an interesting debate.
It really shows how much this field is changing and how people are trying different approaches.
Okay, so we've got these software developing agents,
Right.
but then there are also the ones that are learning to interact with those graphical user interfaces we use every day.
The GUIs, yeah.
And the UITARS paper actually gives a really nice overview of how those had evolved over time.
It does. Like, at first, we had these pretty basic rule-based agents.
Kind of like those old school RPA systems, right? Robotic process automation.
Exactly. Super rigid. They
Yeah.
could only do what they were explicitly programmed to do. Like, if this happens, then do that.
No flexibility.
None whatsoever. If something unexpected popped up, they were totally lost.
So not very intelligent.
Not really. More like automated robots following a strict script.
Okay, so what came next?
Well, then people started developing these things called agent frameworks.
Frameworks.
Yeah, and these were more flexible. They often used these really powerful VLMs, vision language models, basically AI that can both see images and understand text, like some of the latest stuff from OpenAI.
Okay, so they're getting more sophisticated.
Yeah, but you still needed a lot of human input. Like you had to design the workflow and give the VLM very specific prompts.
So still a lot of hand-holding.
Pretty much. The UITARS paper calls this a design-driven approach where humans are kind of calling the shots.
Okay, so we go from rigid rules to more adaptable frameworks.
Right.
And then we get to these native GUI agent models, like UITARS itself.
Exactly. This is where things start to get really interesting. These models are data-driven. They learn directly from massive amounts of data.
So less human engineering, more AI learning from experience.
Yeah. And that data includes everything: perception, reasoning, and action. It's all integrated.
So they're learning the whole process end to end.
Precisely.
And the cool thing is they're pure vision based, right?
You got it.
Yeah.
Their input is just screenshots, like what we actually see on the screen.
Not the underlying code.
Nope. And this is huge because it makes them way more adaptable.
How so?
Well, think about it. Different platforms, different operating systems, they all represent their interfaces differently in code.
Right, so the code can be messy and inconsistent.
Exactly. But the visual representation, that's what's consistent. It's what we as humans actually interact with.
So by focusing on the visual, these agents can potentially work on anything.
That's the idea. More universal, less platform specific.
Pretty amazing. But I imagine building these agents comes with its own set of challenges.
Oh, absolutely. The UITARS paper goes into a lot of detail on this. Like, for starters, there's perception.
Perception.
Yeah, GUIs are super information dense. There's just so much going on, and it's constantly changing.
Buttons, menus, icons, text fields. Yeah, it's a lot to keep track of.
And the agent has to not only identify all these elements, but also understand how they relate to each other spatially and what they do.
So it's not just recognizing a button. It's knowing that that specific button opens a menu or submits a form or whatever.
Right. Context is everything.
And there's reasoning and planning.
Ugh. Yeah, that's a big one. Like, how does the agent figure out the sequence of actions needed to complete a task?
Especially when those tasks might involve multiple steps and navigating through different screens.
Exactly. It's like, okay, I need to get to this final goal, but what's the best path to get there? What buttons do I need to click in what order?
Right, like it's not enough to just see the submit button. It needs to know how to get to that button in the first place.
And what to do before and after clicking it.
And then there's the whole memory thing.
Oh, yeah, that's crucial. The agent needs to remember what it's already done and what the current state of the GUI is.
Like if it's filling out a form, it needs to remember what it's already entered in previous fields.
Otherwise, it's just going to keep asking you for the same information over and over again.
Not very helpful.
Not at all. Then you've got precise actions.
Precise actions.
Yeah, like we can just move our mouse and click.
Right.
But the agent has to output very specific instructions, like the exact coordinates of the click down to the pixel.
Wow, that's intense.
And if it's typing, it needs to know exactly what characters to enter in what order.
No room for error.
And finally, there's this huge data bottleneck.
Data bottleneck, what's that?
It's like, to train these really advanced agents, you need tons of data. High-quality data.
Data of what?
Data of humans actually interacting with GUIs, like what they see, what they think, and what actions they take.
So the agent can learn from those examples.
Right, but that kind of data is hard to come by. It's not like there are just giant data sets of GUI interactions just lying around.
And even if you could collect it, training on all that data would take forever.
Unless you have a way to speed up the training process, which is why what Unsloth AI is doing is so important.
Okay, we'll get to them later. But first, let's talk about UITARS itself.
Yeah.
How does it approach all these challenges?
Well, first of all, its name is pretty cool. It's inspired by TARS, the robot from the movie Interstellar.
Oh, yeah, that was a good movie.
Really smart robot. And that's what the researchers were going for with UITARS. They wanted to create a model that could directly perceive screenshots, reason about tasks, and then actually carry them out, like a human would.
All without those rigid rules or clunky frameworks.
Exactly. They wanted something more integrated, more adaptable, more TARS-like.
So how did they do it?
Well, they focused on a few key areas. First, enhanced perception.
Enhanced perception, what does that mean?
Basically, they built this massive data set of GUI screenshots. But it's not just about the quantity. They used a whole bunch of different tasks to train the model's visual understanding.
Like what kind of tasks?
Well, there's element description, where the AI has to describe what each individual GUI element is.
Okay.
Then there's dense captioning, where it has to describe the overall layout of the interface.
Got it.
And state transition captioning, which is all about understanding the subtle changes that happen after you take an action.
Interesting.
And then there's question answering, where the AI has to answer questions about the GUI's content and functionality. And they even use these visual markers to help the AI connect specific elements to their broader context.
Wow, so they really threw everything at it.
They did. And the goal was to create an AI that can see a GUI and really understand it in a way that's much closer to how humans do it.
Okay, so that's perception. What about the action part?
Well, for that, they focused on unified action modeling.
Unified action modeling.
Yeah, basically, they wanted to create a system where the same action, like click, would work the same way across different platforms.
Whether you're on a desktop, a phone, or a tablet, click always means click.
Exactly. And to do this, they built a huge data set of what they call action traces. These are basically sequences of actions that humans took while interacting with different GUIs.
So the AI can learn from those examples.
Right. And they standardized all these traces into a unified format. They even included special terminal actions like finished to indicate the end of a task,
The AI knows when it's done.
and call user for when it needs help from a human.
Okay, that's smart.
Yeah, it's all about creating a more robust and flexible system.
So we've got perception and action covered. Now, what about the thinking part? The System 2 reasoning mentioned in the paper,
Ah, yes, that's all about deliberate analytical thinking.
as opposed to those quick, intuitive decisions.
Exactly. And to train UITARS for this, they did something really cool. They collected millions of GUI tutorials.
Tutorials?
Yeah, like how-to guides, walkthroughs, that kind of thing.
So they were basically giving the AI a crash course in how to use all sorts of different GUIs.
Exactly. And they use this information to create these thought annotations for their action traces.
Thought annotations.
Yeah, like they describe the reasoning behind each action. So the AI could learn not just what to do, but why to do it.
Okay, so it's not just mimicking actions, it's actually learning the strategies behind them.
Right. And these thoughts could be anything from breaking down a task into smaller steps to recognizing milestones to even reflecting on past actions.
So it's like the AI is learning to think like a human expert.
In a way, yes.
Pretty impressive. But how does UITARS actually get better over time?
Well, that's where iterative refinement comes in.
Iterative refinement.
Yeah, it's a continuous process of learning and improvement. That they basically have the AI explore different GUIs, try to complete tasks, and then they collect data on what it does.
So it's like trial and error, but on a massive scale.
Exactly. And they use all sorts of techniques to filter and refine that data. Like they have rule-based checks, scoring by those VLMs we talked about earlier, and even human review.
To make sure the data is good.
Exactly. And then they feed all that refined data back into the model.
So it's constantly learning from its experiences.
And getting better over time.
And part of this process is something called reflection tuning.
Ah, yes. That's where things get really meta.
Meta how?
Well, they specifically train the AI to recognize when it makes a mistake and then figure out how to correct it.
So it's not just learning from its successes, it's learning from its failures too.
Exactly. They created these special data sets of error corrections, and they used a technique called direct preference optimization, or DPO, to train the model on them.
DPO.
Yeah, it's kind of a way of telling the AI this action is good, this action is bad. Try to do more of the good stuff.
Makes sense.
Mm.
So how well does all this actually work? What were the results of their experiments?
Well, they were pretty impressive. UITARS consistently outperformed existing GUI agent systems on all sorts of benchmarks.
Like by how much?
Sometimes significantly. They also found that DPO was really effective at improving performance, and that scaling up the model size led to better results, especially on those complex online tasks.
So bigger models, better reasoning.
It seems that way. And they also found that the System 2 reasoning, while not always perfect, was really good at generalizing to new, unseen tasks.
So it's not just memorizing solutions, it's actually learning how to solve problems.
Exactly.
Okay, so we've got these really sophisticated GUI agents. But how does that fit into this bigger picture of vertical AI agents that the article was talking about?
Well, the article predicts that these vertical agents, which are basically AI systems tailored to specific industries, are going to be huge.
Huge how?
They're talking about potentially over a $100 billion market by 2032.
Wow, that's a lot of zeros.
Yeah. And they're saying that these agents are going to be able to automate entire processes end to end.
So not just helping humans, but actually replacing them in some cases.
Potentially. And they compare this to the rise of SaaS, software as a service. But they say vertical AI is even bigger.
How so?
Well, SaaS was all about giving businesses better tools.
Right.
But vertical AI is about automating entire workflows. It's a much more fundamental shift.
So, like, instead of just having software to help your customer service team, you have an AI that can handle all the customer interactions on its own.
Exactly. And the article highlights that a lot of startups are really excelling in this space.
Because they're more agile.
Right. They can focus on very specific problems within a given industry, and they don't have all those legacy systems to hold them back.
Makes sense. Do they mention any specific examples?
Yeah, there's Outset, which is using AI for surveys and market research,
Okay.
and A Priora, which is using AI to streamline recruitment.
Interesting.
And then there's Salient, which is applying AI to loan servicing.
Oh, that's got to be complicated.
It's super complicated. They have to make sure everything complies with all sorts of regulations.
Right.
And then there's Sweet Spot, which is using AI for government contract bidding.
Wow, that's a whole other level.
And then there's Show and Tell, which is using AI for personalized dental care.
Wow, AI dentists?
Pretty much. And finally, there's Avatar.ai, which is using AI to revolutionize private jet bookings.
So basically, AI is infiltrating every industry.
It seems that way.
And UITARS, with its ability to understand and interact with GUIs, could be a key enabler for a lot of these vertical agents.
Oh, absolutely. So many businesses rely on GUI-based software for their core operations. If an AI can master those interfaces, it can potentially automate huge chunks of what those businesses do.
Pretty amazing.
It really is.
Okay, so one last thing before we wrap up. We also came across Unsloth AI, the company that's focused on speeding up AI training.
Oh, yeah, they're doing some really cool stuff.
Can you tell us a bit more about what they do?
Sure. Basically, they're trying to make it faster and more efficient to train those massive language models that power a lot of these AI agents.
And how are they doing that?
They're using these really clever techniques, like manually optimizing the underlying math and creating these highly efficient GPU kernels.
GPU kernels.
It's basically code that runs directly on the graphics processing unit.
Okay.
And they're claiming some pretty huge speed-ups, like 30 times faster training in some cases.
That's incredible.
And this is really important because as these AI models get bigger and more complex, training them can take days, weeks, even months.
And that's not practical if you're trying to develop and deploy these agents quickly.
Exactly. So Unsloth AI is basically removing that bottleneck.
Making it easier to build more powerful AI.
Exactly.
So to bring this all back around, what are the key takeaways for our listeners?
Well, I think the big takeaway is that AI is moving beyond those general purpose models. We're seeing a shift towards more specialized agents that can really understand and interact with both our digital devices and the specific needs of different industries.
Right.
And UITARS is a great example of how sophisticated these agents are becoming. They can perceive, reason, act, and even learn from their mistakes, all on their own.
It's pretty mind-blowing.
And with the rise of vertical AI, we're likely to see these agents being deployed everywhere. They're going to automate tasks, optimize processes, and potentially change the way we work in a really profound way.
It's a bit scary, but also exciting.
Definitely. And underpinning all of this is the work being done by companies like Unsloth AI, who are making AI training faster and more efficient, which is going to accelerate all of these trends even further.
So as we wrap up, I want to leave our listeners with a final thought.
Okay.
As these AI agents become more and more capable, what does that mean for us? How will it change the way we interact with technology?
Yeah, it's a good question.
Will we move away from directly controlling our devices to more of a partnership with these intelligent agents?
Maybe we'll be delegating more and more tasks to them.
Or maybe they'll even start making decisions for us.
Who knows? It's a future full of possibilities, but also potential challenges.
Definitely something to think about. Thanks for joining us today.
It's been a pleasure.
And to all our listeners, keep exploring, keep learning, and stay curious.
Because the future of AI is happening now.
And it's going to be a wild ride.
Reverse